Good morning, third grade. This is Miss Glassy, and today I'll teach you a little bit more about finding the area of rectilinear figures. You'll need a pencil and several pieces of paper for today's lesson. If you do not have a pencil and paper in front of you, please pause the video now and get the materials that you'll need. Our target for today is, I will be able to determine the total area of a rectilinear figure with an unknown side length. Let's start by reviewing some important vocabulary you'll need to know. Our first word is rectilinear figure. A rectilinear figure is a polygon with only right angles. A rectilinear figure is a shape you can break apart into rectangles. Decompose. Decompose means to break apart. When you decompose something, all of the parts together are equal to the whole. Area. Area is the total amount of space an object covers. It's the number of square units inside of a shape. When I want to find the area of a rectangle, I multiply the length times the width. You can see here I have an example rectangle. This rectangle is 5 feet wide and 3 feet long. If I wanted to find the total area of this rectangle, I would multiply 5 feet wide times 3 feet long to find the total area. 5 times 3 equals 15, so the total area of this entire rectangle is 15 square units. You have learned how to find the area of a rectilinear figure. You know that in order to find the area of a rectilinear figure, you start by decomposing the rectilinear figure into rectangles. Then you find the area of each of the rectangles. Finally, you add the area of all of the rectangles together to find the total area of the entire rectilinear figure. You can see here I have an example rectilinear figure, and I've already decomposed it into two rectangles. My top rectangle is a 5 by 3 rectangle, and the bottom rectangle is a 2 by 3 rectangle. If I want to find the area of the entire rectilinear figure, I have to add the area of the 5 by 3 rectangle plus the area of the 2 by 3 rectangle to find the total area of the entire figure. 5 times 3 equals 15. So the area of the first rectangle, the 5 by 3 rectangle, equals 15 square units. 2 times 3 equals 6. So the area of the 2 by 3 rectangle, second rectangle, is 6 square units. If I want to find the total area of the entire shape, I add together 15 square units, the area of rectangle 1, plus 6 square units, the area of rectangle 2, to find the total area. 15 plus 6 equals 21. So the total area of the entire rectilinear figure is 21 square units. Yesterday, you learned about finding a missing side length on a rectilinear figure. Let's review briefly what we know about wholes and parts and how that helps us find a missing side length on a rectilinear figure. You've learned that opposite sides of a rectilinear figure are the same length, but sometimes a side length is broken into parts. Let's start by looking at the horizontal side lengths, or the side lengths that go side to side. One horizontal side length is this 10-inch side length here. Another horizontal side length is side length G, and there's a third horizontal side length, this 2-inch side length here. I'm going to look at these three side lengths and determine which side length goes the whole distance of the entire rectilinear figure. I can see that the entire horizontal side length of this figure goes from here to here, or from here to here. It is easy for me to see that the 10-inch side goes the whole length of the entire rectilinear figure, so it is the whole. I can also see that side G only goes part of the length of the rectilinear figure, so it is a part, and side length 2 also only goes part of the way. Now I can see that my unknown side length, the side length I don't know, is a part. When a part is missing, you know that we need to subtract, because whole minus part equals part. I would subtract the 10-inch side, the whole horizontal side length, minus the 2-inch side length, the horizontal side length part that I know, and that, third grade, will equal G, my unknown horizontal side length. 10 minus 2 equals 8. So the length of side length G is 8 inches. Let's look now at the vertical side lengths. I can see that one of the vertical side lengths is this 4-inch side length here. Another vertical side length is this 1-inch side length here. And a third vertical side length is vertical side length R, our unknown vertical side length. I can see that the entire vertical side of the rectilinear figure goes from here all the way to here, from here all the way to here. It is easy for me to see that side length R goes the whole vertical side length of the entire rectilinear figure, while the vertical 4-inch side only goes part of the way, and the vertical 1-inch side also only goes part of the way. That makes it easy for me to see that our missing side length R, is the whole vertical side length of this rectilinear figure. When we are missing a whole, we add, because part plus part equals whole. To find missing side length R, I will add the part 4 plus the part 1 to equal missing side length R. 4 plus 1 equals 5. So the length of side R is 5 inches. Now, third grade, we're ready to begin finding the area of rectilinear figures that have a missing side length. Here is a rectilinear figure that we need to find the area of. I can see that one of the side lengths on this rectilinear figure is missing. When I want to find the area of a rectilinear figure that has a missing side length, I like to start by finding the missing side length. I can see that side length K is an unknown side length. It's a horizontal side, a side that goes side to side. I'm now going to identify the other horizontal sides on this rectilinear figure. I can see that the 4-inch side here is also a horizontal side, and so is this 3-inch side, because they all go side to side. I can see that the total horizontal side length of the entire rectilinear figure would go from here to here, from here to here. It is now easy for me to see that side K goes the whole horizontal distance of the rectilinear figure, so side K is the whole. This 4-inch side goes part of the horizontal distance, and the 3-inch side goes part of the horizontal distance, so they are both parts. The side that we're missing goes the whole horizontal length of the rectilinear figure. When a whole is missing, third grade, we add, because part plus part equals whole. So to find missing side length K, I'm going to add. One of the horizontal side length parts is 4, and the other is 3. So I'll add 4 plus 3 to find missing side length K. 4 plus 3 equals 7. So the length of the missing side length K is 7 inches. Now that we know all of the side lengths of this rectilinear figure, we're ready to decompose it to find the area of the entire figure. Take a moment and think, third grade. How could we decompose this rectilinear figure into rectangles? I'll bet that you could find 2 different ways we could decompose this shape into 2 rectangles. Take a moment and think. I'll bet you found that we could split it vertically or horizontally to create 2 rectangles from this rectilinear figure. We'll go ahead and split it horizontally to solve this problem, although either way would be just fine. Now, third grade, let's take a look at these 2 rectangles and find the area of each rectangle. I'll outline rectangle 1 in purple so it's easy for us to see. What is the size of this rectangle? Rectangle 1. This rectangle is a 7 by 2 rectangle. 7 times 2 equals 14. So the area of rectangle 1 is 14 square units. Now let's take a look at rectangle 2, which I'll outline in green. Here is rectangle 2. Let's figure out the size of this rectangle. I noticed something funny about this rectangle, third grade. One of the vertical side lengths is 6, and the other vertical side length says 8. We need to use our mathematical reasoning to determine if the vertical side of rectangle 2 is 6 inches or 8 inches. Well, I can see that this 6-inch side starts at the bottom of the rectangle and goes all the way to the top of the rectangle we're talking about, but it does not go all the way to the top of the rectilinear figure. I can see that the 8-inch side starts at the bottom of the rectangle too and goes all the way to the top of the whole rectilinear figure, past the end of the rectangle that we're talking about. That's because the whole length of the entire vertical side of the rectilinear figure is 8 inches long. But we've split the horizontal length of the rectilinear figure here. We split this 8-inch side into a 2 and a 6. That makes sense because 2 plus 6 equals 8 inches. I could check this further by using what I know about opposite sides of a rectangle, that they're the same length. I think that this part of the vertical side is 2 inches long. I can see that I've made rectangle 1 and that the opposite side of rectangle 1 is 2 inches long. That helps me know for sure that this part of this side of the rectilinear figure is also 2 inches long. I'm thinking that this part of this vertical side is 6 inches long. I'll look at the opposite side of this rectangle and I see that it's also 6 inches. That helps me know that this rectangle is 6 inches long. So this rectangle is a 4 by 6 rectangle. 4 times 6 equals 24. So the total area of rectangle 2 is 24. Now I'm ready to go ahead and find the area of my rectilinear figure. I know that I need to add rectangle 1, the 7 by 2 rectangle, plus rectangle 2, the 4 by 6 rectangle, to find the total area. 7 times 2 equals 14. I'm going to add that to the area of the 4 by 6 rectangle. 4 times 6 equals 24. So I'm going to add the area of rectangle 1, 14 square inches, plus the area of rectangle 2, 24 square inches, to find the total area of the entire rectilinear figure. I'm going to add 14 plus 24 vertically, so that I make sure I'm doing my best adding. I can see that 14 plus 24 equals 38. So the total area of the entire rectilinear figure is 38 square inches. Very good, third grade. Let's take a look at another example. Here's another rectilinear figure. We're going to find the area of this rectilinear figure, but I can see that one of the side lengths is unknown. Side length n is unknown. Side length n is a horizontal side length. Let's go ahead and identify the other horizontal side lengths of this rectilinear figure. Which other side lengths are horizontal side lengths? I respectfully agree. The 8 centimeter side and the 9 centimeter side are both also horizontal side lengths. I can see that the horizontal side goes from here to here, from here to here. Now it is easy for me to see that the 9 centimeter side goes the whole horizontal length of the entire rectilinear figure. So it is our whole. I can see that the 8 centimeter side goes part of the horizontal distance and that side n goes part of the horizontal distance. So they are both parts. I can easily see now that our unknown side length is a part. And when a part is missing, I know that we need to subtract, because whole minus part equals part. On your paper, third grade, please write this down with me. I would like you to find on your paper the length of side n. Pause the video and find the length of side n. Press play when you're ready to check. Are you ready to check the length of side n? I'm sure that you did our whole 9 centimeters minus the part we know, 8, to equal n, our unknown side length. 9 minus 8 equals 1, so the length of side length n is 1 centimeter. Very good, third grade. Now that we know the length of every side of this rectilinear figure, we're ready to find the area of the rectilinear figure. Let's go ahead and decompose this rectilinear figure into 2 rectangles. I'll give you a moment to think. Can you find two different ways we could decompose this rectilinear figure into rectangles? I'll bet you realized we could decompose this rectangle vertically or horizontally to create two rectangles. We'll go ahead and split this rectilinear figure vertically, like this. Let's go ahead, third grade, and determine the area of our first rectangle. We'll call this larger rectangle Rectangle 1. I'll outline it in purple. I'll give you a moment to think about the size of this rectangle and determine the area of Rectangle 1. This rectangle is an 8 by 10 rectangle. I'll bet you had to think for a moment if it was an 8 by 10 or a 9 by 10, but you realized that 9 is the length of the entire figure, but 8 is the length of this rectangle. 8 times 10 equals 80, so the area of the first rectangle is 80 square units. We'll go ahead and look at rectangle 2, this small rectangle here. I'll give you a moment to determine the size of this rectangle. Remember, side N was 1 centimeter long. Go ahead and find the size of this rectangle and the area of rectangle 2. Rectangle 2, the green rectangle, is a 1 by 7 rectangle. 1 times 7 equals 7. So the area of the second rectangle is 7 square units. Now, third grade, I'd like you to use mathematical equations to represent your thinking on your paper. Please pause the video now and find the area of the entire rectilinear figure. Press play to check it. Are you ready to check your mathematical representation and the total area of this rectilinear figure? Great. You know we need to add together rectangle 1, the 8 by 10 rectangle, plus the area of rectangle 2, the 1 by 7 rectangle. And when we add those together, it will equal the total area of the entire rectilinear figure. You know that the area of an 8 by 10 rectangle equals 80, and the area of a 1 by 7 rectangle equals 7. So we need to add 80 square units plus 7 square units, the area of both rectangles, to find the total area of the entire shape. I'm sure you added 80 plus 7 vertically to make sure you were adding correctly, and you realized that 80 plus 7 equals 87. That means, third grade, the total area of the entire rectilinear figure is 87 square centimeters. Let's do one more practice problem together. Here's another rectilinear figure that we need to find the area of. Again, I notice that one of the side lengths is missing. The missing side length R, is a horizontal side length. Find the other horizontal side lengths on this rectangle, and then find the missing side length of side R. I'll give you a moment to pause the video and determine the missing side length R. Press play when you're ready to check. Are you ready to check the missing side length R? I'm sure you determined that the other horizontal side lengths were the 11-foot side length and the 5-foot side length. Then you thought about the total distance, the total horizontal distance of the entire rectilinear figure, which goes from here to here, from here to here. Once you thought about that, it was easy for you to see that the 11-foot side goes the whole distance of the entire rectilinear figure, while side R and the 5-foot side both only go part of the way. You know that side R is a part, and when a part is missing, you subtract, because whole minus part equals part. I'm sure you subtracted 11 minus 5 to find the missing side length R. 11 minus 5 equals 6. So missing side length R equals 6 feet. Very good, third grade. We're going to go ahead and decompose this rectilinear figure now so that we can find the total area of the entire shape. There are two ways we could decompose this rectilinear figure, and I'll bet you can think of both of them. I'll bet that you determined we could split this either vertically or horizontally to create two rectangles. We'll go ahead and split this rectilinear figure horizontally with a large rectangle on the top and a smaller rectangle on the bottom. We're going to call the top rectangle rectangle 1 and the bottom rectangle rectangle 2. I would like you to determine the area of each rectilinear figure and then add those areas together to find the total. Oh, I'm sorry, I misspoke. I'd like you to find the area of each rectangle and then add them together to find the total area of the entire rectilinear figure. Once you've determined the area of the entire rectilinear figure and you're ready to check your answer, I'd like you to press play. You may pause the video now to find the area of the entire shape. Are you ready to check the area of the entire rectilinear figure? I'm sure you noticed that the area of rectangle 1 is a 5 by 11. You know you needed to add a rectangle 1 plus rectangle 2. Rectangle 2 was a 5 by 5 rectangle. You'll add those together to find the total area of the entire rectilinear figure. Rectangle 1, the 5 by 11 rectangle, has an area of 55 square units. Rectangle 2, the 5 by 5 rectangle, has an area of 25 square units. You'll add those together to equal the total area of the entire shape. I'm sure because you're very diligent that you added 55 plus 25 vertically to find the total area of the entire shape, regrouping carefully when you needed to. You found that 55 plus 25 equaled 80. So the total area of the entire rectilinear figure was 80 square feet. Great job, third grade. You are now ready to complete your assignment independently.